Prove that the ideal A0 equals to A of a Euclidean ring R is generated by A0 is a maximal if and only if A0 is a prime element of R. Now prove let A is a maximal ideal of R. We shall prove that A0 is a prime element of R. Let A0 equals to BC, where B and C belongs to R. Let capital B equals to small b equals to BR. Then A contains in B. Since A is a maximal, either B equals to A or B equals to R. If B equals to A, then small b belongs to capital B, which implies B belongs to A, but A equals to small a0 equals to a0r. So B belongs to A, which implies B belongs to a0r, which implies a0x for some x belongs to R, which implies B equals to a0x since a0 equals to bc, which implies a0 equals to a0xc because b equals to a0x, which implies a0 minus a0xc equals to 0, which implies a0 into 1 minus xc equals to 0, which implies 1 minus xc equals to 0. A0 not equals to 0 because a0 equals to 0, which implies a0 r equals to 0, a contradiction, which implies xc equals to 1, which implies c is a unit. If b equals to r, then 1 equals to b equals to small br, which implies 1 equals to by for some y belongs to R. So 1 equals to br, which implies b is a unit. Hence a0 is a prime. Conversely, let a0 be a prime element of R. If a equals to a0 R is not a maximal, there exists an ideal of B of R such that A is a subset of B is subset of R. Since every ideal of an Euclidean ring is a principal ideal and the Euclidean ring has unity, there exists B small b belongs to capital B such that B equals to small br. Then A0 belongs to A contains in small br because A is a subset of B, and small a0 belongs to A contained in br, which implies a0 equals to bc for some c belongs to R. Since a0 is a prime, either B is a unity or C is a unit. If B is a unit, then B belongs to B R equals to R is a contradiction. If C is a unit, then there is a C dash belongs to R such that C dash equals to 1. Therefore a0 C dash equals to BC into C dash equals to B into C dash equals to B into 1, which implies a0 C dash equals to B, which implies B equals to a0 C dash, which implies B belongs to a0 R, which implies BR contains in a0 R, that is B equals to A, again a contradiction. Therefore there is no ideal of B in R with A is a subset of B is a subset of R, and A is a maximal ideal of R.